Thank you everyone for coming today. I'm here to present the University of North Carolina-Wilmington's greenhouse gas inventory. My name is Seth Jansen, and I'm with an engineering firm called Brendle Group from Fort Collins, Colorado, and we've been working with various folks on campus over the last 6 months or so to put together a greenhouse gas inventory for your campus operations, and I'm here to explain that little story today. So first, a little bit about sustainability at UNCW. You have a lot of activity going on right now in this room, and what you see on the slide here is just a brief snapshot of those activities. You have a sustainability committee that is coordinating and helping to drive a lot of this work. You've been doing performance contracting to reduce your energy consumption on campus. For anyone who's walked around recently, there's a lot of new and renovated buildings that have a lot of great green features in them, including some LEED buildings. The transportation options for students and faculty and staff have opened up a lot over the last few years. You've got a new bike path, increased bike parking, has a couple of examples. And your access to recycling and the number of materials that you can recycle has also improved over the years. So there's a lot of activities going on in food services, really all across campus. And the greenhouse gas inventory is just kind of another piece in that puzzle, another tool for you to use as you're evaluating future activities, judging your progress, and also comparing your institution to other institutions. So why a greenhouse gas inventory? A lot of schools are preparing these inventories and reporting their emissions publicly. So doing this inventory for UNCW prepares you to join that group of other higher education institutions doing that work. There's also a few specific higher education programs that are working in the area of sustainability in general, but both include greenhouse gas inventory reporting. An example of one of those is the American College and University President's Climate Commitment. I'll call it ACUPAC from here on out, because that's otherwise kind of a long statement. And that organization has about 675 signatories, colleges and universities across the country who've committed to that agreement. 22 of those are in North Carolina, and roughly 7 of the schools in the University of North Carolina system have committed to that agreement. And what those schools have committed to doing is a greenhouse gas inventory, which now UNCW has completed. The other components of that commitment are a climate action plan, 2 years into it, which is a plan to detail the university's plan to get to climate neutral. And that is the ultimate agreement that is required in that commitment. That's the ultimate commitment, is to achieve climate neutrality for the university organization. I think it was a good move by UNCW to do an inventory first before signing this agreement. A lot of schools that we've worked with have gotten into it, signed the agreement first, then done their inventory and realized that it's not an easy goal. It's a very ambitious goal, and it's nice to have the information before committing to that. The other sustainability program that a lot of higher education institutions are working in right now is the Association for Advancement of Sustainability in Higher Education, ASHE's STARS program, which is the Sustainability Tracking, Assessment, and Rating System. And this isn't a ranking tool, it's a rating system, and it's much broader than just greenhouse gas emissions. It includes campus operations, educational and curriculum activities, research activities on campus, how the campus is planning for sustainability, the way the administration is tied into sustainability decision making, and also innovation with respect to sustainability on campus. So STARS is a lot broader than ACUPAC in terms of the kind of issues they're trying to address. And right now they have 296 higher education institutions participating. About 11 of those are in North Carolina and 4 within the University of North Carolina system. And so having a greenhouse gas inventory now, UNCW is prepared to participate, at least with respect to that component, in either one of these programs if they should choose to do so. And the inventory we've completed will meet the requirements of both. Oops. A little bit about how we approach a greenhouse gas inventory. There's kind of 4 key tenets to the inventory itself. First off, we want to make sure it's complete. So we address all the emission sources that are required by the protocol, but also that we're trying to address them as completely as possible and getting all the last little bits of data that might be hiding out in the various corners of your organization. We try to be consistent, so we do apply a protocol and use the emissions factors and the methodology consistently across all the emission sources. We try to be accurate to the extent that's necessary. So we're going to get all of the data that we can. We're going to apply those emissions factors consistently. And we're going to try to reach down and get every last bit of detail that we reasonably can. So for example, for UNCW, one of the challenging areas to gather data in is some of that other travel that you do off campus, rental cars, ferry travel. You have a lot of students and staff that are traveling for various activities outside of the campus area. So we gathered as much data as we could there, and we made a reasonable estimation of emissions, but it's not exact. In the end, you kind of have to balance the level of effort that you're investing in measurement with what you can reasonably manage. And finally, we've tried to be very transparent. We'll be delivering all the materials from the inventory and the complete process of calculation to UNCW, so you'll have access to that information. And we've also written a full written report that has a lot of that detailed as well. And to the right side of the slide here, you see kind of our process in generating the inventory. First, we worked with UNCW staff to identify the boundary and what methodology we wanted to use. Then we've identified the various data sources and collected the data, compiled and analyzed that data, and then iterated with UNC staff to make sure that we've gotten it correct. A little bit on the structure of the inventory. We've used the GHG corporate accounting protocol as kind of the overarching guidance for the inventory. It's widely accepted and used in industry throughout the US and actually the world now. And the two specific tools we've used under that are the Clean Air Cool Planet tool, which is a spreadsheet-based tool that is recommended by AccuPack and can be used for STARS as well to calculate your greenhouse gas emissions. And then to support that tool, we developed another spreadsheet-based tool called an inventory management system that kind of documents all the background information that goes into the Clean Air Cool Planet tool. For Clean Air Cool Planet, we've used version 6.6, which was the most recent available when we started the inventory process this summer. Version 6.7 was just recently released, and that'll be easy for University of North Carolina-Wilmington to update too when they're ready to do that. And our inventory management spreadsheet is just Excel-based. It's very straightforward, and that collects all that raw data and kind of shows you the process from the raw data to where it gets input into the Clean Air Cool Planet tool, so that all the assumptions about figuring out what data falls into what fiscal year and so on are outlined in there. So one of the first decisions we needed to make was what boundary to draw in terms of what emissions to include in the inventory. And we did that based on an operational control approach. So basically anything that UNC has the capacity to influence the operation of, we've included in the inventory. And there are some gray areas where, in leased space it can be unclear, for example, who really has operational control of the space. And so we've erred on the side of including more in the inventory. So anywhere we were unsure, we've included the information. So we've included main campus, the Center for Marine Science, and a number of off-campus facilities, including the Harbor Island Research Facility, the Aquarius Reef Base, and the Airlie Commons facility as well. So when we talk about a greenhouse gas inventory, what's included there? So basically we're looking at the 6 Kyoto Protocol greenhouse gases or classes of gases. Carbon dioxide, which you're all familiar with. That one makes up about 80% of all greenhouse gas or global warming potential in emissions in the United States, and is also the most prevalent gas in your inventory, as you might expect. Methane and nitrous oxide are the next two very common gases. They make up another roughly 18% of the US inventory and are also the next most prevalent in your inventory. And then the last 3 classes of gases, perfluorocarbons, hydrofluorocarbons, and sulfur hexafluoride are much smaller quantity emissions of those gases, and they do have a fairly high global warming potential. Any one of those gases has a much bigger impact on global warming than carbon dioxide or methane, for example, but they're emitted in much smaller quantities. So we've included those as well. And we divide these gases into 3 different scopes. The first is scope 1, which is direct emissions. So these are emissions that occur on campus as a direct result of your activities here. So you could literally, the analogy I make is you could go out with a plastic bag and actually capture these gases in the bag. Scope 2, which we separate, are energy emissions from energy you're purchasing, where that energy is generated somewhere off-site. So this is basically your electricity that's purchased from off-site. And the reason we separate those two is that the power plant is going to calculate their emissions and count that as their Scope 1, and we don't want to count those emissions twice. So when we look at emissions from a bigger, higher level, bigger picture, the reason they're divided into scopes is to prevent double counting. And then the last scope is Scope 3, which are your indirect emissions from other activities, demand that's generated by the university, but the emissions aren't directly in your operational control. And so those are emissions from things like directly financed air travel, your solid waste that goes off-site to be managed, faculty, staff, and student commuting, and the purchase of materials and goods that you bring onto campus. And so some of the specific emission sources that we see at University of North Carolina-Wilmington are stationary combustion of fuels. So we're in that Scope 1, those are direct emissions. And that's natural gas, propane, and a little bit of stationary oil, or residual oil on campus. Your university fleets, of course. Refrigerants that leak from air conditioning equipment and refrigeration equipment on campus. And fertilizer application. Then we have Scope 2, which I said is really just the electricity that you're purchasing and consuming. And Scope 3, where we've included faculty, staff, and student commuting, university-financed air travel, solid waste disposal, wastewater treatment, and embodied emissions in purchased paper. That Scope 3 category is one that's expanding a lot right now in terms of how it's treated in protocols. The World Resource Institute fairly recently released a new protocol for accounting for Scope 3 emissions that divides those emissions into 16 different categories, all up and down your supply chain, and including some of these specific areas we've looked at here. And so I think we're going to see a lot more accounting in the Scope 3 in years to come. But for now, we've included the ones that are required by AccuPack, which is the commuting, directly financed air travel, and the solid waste, wastewater treatment, and embodied emissions and paper purchases. And so the results. In fiscal year 2010, the total emissions that we've estimated for University of North Carolina-Wilmington are 69,621 metric tons of carbon dioxide equivalent. And so by carbon dioxide equivalent, that's a unit that collapses the impacts of all those different gases into a single common unit. So 1 metric ton of carbon dioxide yields 1 metric ton of carbon dioxide equivalent climate impact. 1 metric ton of methane yields 21 tons of carbon dioxide equivalent in terms of climate impact. So when you lump all those gases together in that common unit, you get the roughly 69,000 metric tons of impact. And as you can see from the pie chart, that's primarily energy consumption in buildings on campus. That's about 65% of emissions. Transportation makes up an additional 26% roughly, and that includes both the commuting, your university fleet, as well as the finance travel, student travel, and study abroad travel. And the remaining other category there, which makes up the relatively small 8.5%, is refrigerants, those Scope 1 refrigerants, fertilizer application, transmission and distribution losses in bringing electricity to the campus, and the purchased paper. And you don't see solid waste on this chart because given the emissions factor that's attributed to the type of solid waste disposal you have at a waste-to-energy facility, there's actually a small carbon credit attributed to that process on a national average basis. And so that's why you don't see that in this chart. It actually is a small credit against your emissions. So these are the same results again in tabular fashion. And so the trend of University of North Carolina-Wilmington's emissions from fiscal year 07 to 2010 is fairly level. I will point out on this graph that fiscal years 7 and 8, the first two on the left there, are lacking in the study abroad travel, airline travel data. So they're actually higher, emissions are actually higher in those years, and so it really is more of a flat trend. If we take those study abroad emissions out and look at the change from fiscal year 07 to 10, it's increase of roughly 1.5% in emissions. Over that same period, the student population has increased 7.3%, and the building square footage on campus has increased by 40%. So you can see that in terms of the efficiency of what you're doing in delivering education to students and providing that infrastructure, you're doing pretty well to have kept the emissions so constant over the last 4 years. And then there's a few other trends here on specific emissions categories. In the upper left-hand corner is stationary fuels, both total emissions and emissions per square foot of building space. You can see both of those have trended down since fiscal year 06 in that case. We had data going back a little further. Electricity, you see that the total emissions from electricity have increased rather substantially over that period, but with the addition of a lot of additional building square footage, the emissions per square foot have actually been trending down, so you're getting more efficient in how you're using that electricity given the amount of square footage that you have. And then the lower graph here is total emissions and emissions per student for the university fleet, which you can also see both have been trending down over the last 5 years. A little bit of benchmarking against peer institutions. I'll start out with a caveat that benchmarking is challenging. All these schools are very different. They're providing different types of education, different amounts of laboratory space, for example. They're in different climates. So there's a lot of considerations to take into account when you look at comparing emissions between schools. But you can see we have a number of peer institutions here with fairly recent inventories completed in the last 2 to 3 years. We tried to find the most recent data available, and all this data was collected through AccuPack reporting. Full-time equivalent students range from about 6,000 at the College of New Jersey to almost 20,000 at UNC Charlotte. Building square footage from about 2,500 at the University of Wisconsin Eau Claire to about almost 7 million square feet at UNC Charlotte. And emissions range from anywhere at about 26,000, 27,000 at the University of Wisconsin to about 85,000 at UNC Charlotte. And when we look at these on a per student and per square foot basis, we can make a little bit of comparison there. So on the left, you see a chart that is metric tons of carbon dioxide equivalent per year per full-time equivalent student. And right now we're looking at just the scope 1 and 2 emissions. So these are just those direct emissions on campus from natural gas, from university fleets, and from purchased electricity. And the reason we focus on these is there's typically better data for those, and so we can more readily make comparisons between schools on those scope 1 and 2 emissions. And you can see on those that with about 4 metric tons of carbon dioxide equivalent per student per year, UNCW falls pretty much right in the middle of the field on that metric. And then on the graph at the right is metric tons of carbon dioxide equivalent per 1,000 square feet per year. On this graphic, you can see UNC appears to be a little higher up at 15.1 metric tons per 1,000 square feet per year. But when you really look at the band of schools that are right in the middle, where University of North Carolina-Wilmington is very comparable on a per student basis, you move to the higher end of the comparison on a square foot basis because you have a lot higher density. You have more students per square foot than some of these other schools that are kind of in that comparable region on a per student basis. So all that airline travel that those students do, all your university fleets, that quantity of emissions is basically being packed into a smaller amount of square footage. So when you consider that, again, you're pretty comparable there on a per square foot basis. So where does that leave us? You now have a greenhouse gas inventory that you can use to track progress with respect to some of your other activities and sustainability from year to year. You have one of the base requirements of signing the AccuPack agreement and a tool to use in considering whether that's something the school wants to do. You have another key component of the ASHE STARS program. So you're on the way to potentially participating there if that's something you should choose to do. And regardless of what you do with respect to either of those other programs, I would certainly encourage continued planning and progress on the part of the Sustainability Committee in moving toward greater efficiency in energy consumption and a reduction of your greenhouse gases overall at UNC Wilmington. So with that, I want to thank Stan Hartz, Environmental Health and Safety Director, who was instrumental in organizing this project and getting the work done. And then all of these people that are listed to the right here who've provided data that contributed to this process. So thanks for your time, and with that, I'll take any questions. All right, so the first question that we had was, in general, how are greenhouse gas emissions calculated? Very little of these type of greenhouse gas inventories are done based on direct measurement. Typically, we take some kind of activity data, like the number of kilowatt hours of electricity consumed or the number of therms of natural gas, and then we multiply that based on the methodology that we're using by an accepted emissions factor that converts that unit, like kilowatt hours, to metric tons of carbon dioxide equivalent. And so that's what we've done with all of the emissions for UNC Wilmington based on accepted emissions factors for the Clean Air Cool Planet tool. The next question was the Scope 2 electricity emissions. How are those calculated and how accurate are they? So in terms of how they're calculated, as I mentioned, we're looking at the number of billed kilowatt hours. So how many did you actually pay for from your utility? So that component of it is very accurate, obviously, because you only want to pay for what you used. Then we multiply that times a regional emissions factor for your electricity grid. And for UNCW, that's based on a region that includes, it's basically a southeast region that includes predominantly North Carolina and a little bit overlap into other states. So obviously that factor is going to be a little bit less accurate depending on where exactly your electrons come from. Ideally, when possible, we look to the regional utility to see if they can say specifically what power are they generating and what power are they purchasing. And we weren't able to answer that question for UNCW, so we're using that slightly more regional factor. A sub-question to this that was raised is that the local utility is planning a conversion of a local facility from coal to natural gas, and how will that impact emissions for UNCW? The answer is that it would, assuming that that facility is supplying electricity to UNCW, it would reduce emissions. Now the regional grid factor will take that into account eventually, that conversion of that facility, but the two issues with that are that those factors are fairly delayed in when they're prepared. Typically a few years pass between when the consumption occurs and when the factor is available. And at the regional scale, the impact of that single plant conversion is not going to be very noticeable in your emissions factor. So hopefully what you can do in future inventories is look to your utility to find out what their mix is, what their emissions factor is, if they've calculated that number by then, and account for that local plant converting from coal to natural gas at that stage. Another question that was asked is, why do you receive a carbon credit for your waste over the period of this inventory, and what's going to happen to that in the future? Over the period of this inventory, your waste hauling provider said that the majority of your waste went to a waste-to-energy facility. And so there's a slight carbon credit there because you're avoiding emissions at a landfill from some of that waste decomposing, and you're also avoiding some emissions on the electricity grid because of the electricity that's generated at that waste-to-energy facility. So that's the reason for the credit over the period of this inventory. In the future, that facility has been shut down, and its potential for reopening is currently unknown. So in the future, as your waste is most likely predominantly going to a landfill instead, that will lead to an increase in emissions from solid waste. And based on your inventory, it's likely to increase your emissions by probably 2 to 3% overall. And that's just a guess based on standing up here, but that's the best guess I can make right now. Another question was, how do we calculate the impact of faculty, staff, and student commuting? By working with your parking services office, we were able to get GIS data that indicated where faculty and staff lived based on where their address is when they pulled their parking permits. So we're able to tell how frequent or how far people are commuting from, and then we used some kind of best practices in the industry in terms of estimating frequency of commute and mode of commute in order to generate a value for the greenhouse gas emissions from commuting. Are student vacations included in the either the air travel or commuting components of the inventory? And the answer is no. Student travel to and from the university, either at the beginning or end of the semester or for vacations, is not included. The directly financed air travel includes travel that's really financed through the university on university business, so conferences, and study abroad is also included. What's the impact of composting on greenhouse gas emissions? The detailed answer is it depends on how you manage your compost. In some cases, it can increase emissions. In some, and in many, it reduces emissions. AccuPack and the standard factor that it uses for composting does assume a benefit, a credit for composting, and it's not a very large credit, but you do see some benefit certainly from diverting waste from the landfill where you would have had a greenhouse gas penalty toward composting where you see a small credit. What credits are recognized by AccuPack as organizations pursue climate neutrality? AccuPack recognizes, as I mentioned, composting for a small credit. It also recognizes the purchase of renewable energy credits or carbon offsets toward achieving climate neutrality. And then the last question, also from AccuPack, or related to AccuPack, is part of that agreement is setting a goal for climate neutrality for the organization. And the question was, what is the time frame for when schools are targeting to achieve climate neutrality? And the answer is that it's widely varying. Some schools claim to have achieved it already through various means. Others have not made a plan yet. But I would say, based on our work and our experience with the schools that we've worked with, the 2050 horizon is fairly common for what schools are claiming as a reasonable time to achieve climate neutrality.